Hello, everyone. Welcome to this special webinar on the Southern Plains drought and heat. My name is Joel Lisenby, and I'm the Southern Plains Drought Early Warning System Coordinator at NOAA's National Integrated Drought Information System, or NIDIS. I also am at the Cooperative Institute for Research in Environmental Sciences at the University of Colorado in Boulder. I would like to thank all of you for joining us today. I'd also like to thank everyone who worked so hard to put this webinar together, including our partners at the National Integrated Heat Health Information System. We're going to be hearing from them in just a minute. First, allow me to cover some housekeeping items. On this webinar, everyone is muted. The webinar is being recorded, and the webinar recording will be put on the NIDIS YouTube channel. We'll also be posting it on drought.gov. If you go to drought.gov/webinars, you can find it there in a few days. We have some time on the agenda throughout this webinar to take a few of your questions. When it comes to question time, please use the questions box in GoToWebinar. It's a little different than the chat box. It says questions on it. Go ahead and type your question in full the way that you would like us to read it to the presenters. And we would appreciate it if you would include your name and your affiliation when you do that. So that's the housekeeping items. Next, I'm honored today to be able to introduce Dr. Sarah Kapnick to open this webinar. Dr. Kapnick is the recently appointed NOAA Chief Scientist. She brings a wealth of expertise at the intersection of climate science and economics, and she returns to NOAA after a role as managing director at JP Morgan. Her previous NOAA experience spans 10 years at the Geophysical Fluid Dynamics Laboratory in Princeton, New Jersey, where Dr. Kapnick conducted research on seasonal climate predictions, mountain snowpack, extreme storms, water security, and the market impacts of climate change. Unfortunately, Dr. Kapnick couldn't be here in person today, but we're very grateful that she's recorded her remarks. So now over to NOAA's Chief Scientist, Dr. Sarah Kapnick.
Hello, my name is Dr. Sarah Kapnick, and I am the new NOAA Chief Scientist. This is my second full week on the job, and I am thrilled to provide these remarks to kick off today's webinar, focusing on drought and heat across the Southern Plains of the United States. In just a moment, you will hear an overview of current drought, heat, and fire conditions around the region. These are issues I care deeply about. I'm a hydroclimate scientist by background, having studied issues of water availability and drought. But I also have family in West Texas telling me about the extreme conditions they're experiencing. According to the most recent U.S. Drought Monitor, over 85% of the Southern Plains is currently in drought. 42% of the Southern Plains is in extreme or exceptional drought. The last time this region saw a drought of this magnitude was the record-setting 2011 to 2012 drought. In Texas, nearly 94% of the state is in drought. Soils are very dry, and wildland fire potential is elevated across the entire state. In Oklahoma, much of the state is showing extreme large wildfire potential, with wildfires currently ravaging the state. For the last 2 years, La Niñas have been a factor in decreased winter precipitation across the southern United States, especially in Texas. A third La Niña winter could form, indicating the potential for another dry winter. Drought is expected to continue into the summer with significant impacts. We're seeing this in agriculture with stress to crops, and with livestock with heat stress and health for livestock. We also are seeing drought taking a toll on the region, with conditions in Texas and Oklahoma are rapidly deteriorating. Extreme summer temperatures are exacerbating this problem. Extreme heat is the deadliest weather-related event in the United States. Summers have been getting hotter, with July of 2021 registered as one of the hottest months ever recorded on Earth. Increasing summer temperatures put citizens at higher risk of heat-related illness or death, and as climate change worsens, summers will continue to get hotter and potentially more deadly as a result. Extreme heat impacts all of us. It impacts rural, urban, and tribal communities. It impacts the electricity and utility sectors, transportation, healthcare, military and defense operations, and agriculture. It can even cut short sporting events and college graduations. However, heat-related illnesses and deaths are avoidable. It will take all of us working together to address the challenges of drought and extreme heat to reduce these impacts. NOAA remains dedicated to the delivery of heat and drought early warning systems and response information that decision makers need as you grapple with extreme heat and exceptional drought conditions across the Southern Plains. The challenges require interagency cooperation and coordination across all levels of government. The Southern Plains Drought Early Warning System, supported by NOAA's National Integrated Drought Information System, or NIDIS, represents a cross-sectoral intergovernmental partnership dedicated to building drought early warning capacity in the region with the ultimate goal of making the Southern Plains more resilient during times of drought. Many of the drought products developed by NOAA and our partners are featured in today's webinar to help stakeholders and the public monitor and prepare for drought. These include the U.S. Drought Monitor, monthly and seasonal U.S. Drought Outlooks, and the drought information statements from the National Weather Service. The heat outlook that will be shared today is a joint effort between the CDC, NOAA, and the National Institute of Environmental Health Sciences. It was developed through NOAA's National Integrated Heat Health Information System, or NIHHIS, with support from the U.S. Global Change Research Program, and later operationalized at the CDC. It is built off of NOAA's Climate Prediction Center's one-month seasonal climate outlook. NIHHIS works with local governments and community stakeholders by supporting citizen science urban heat island mapping campaigns, enabling residents to observe and map their own heat islands, showing where action can be taken to reduce risks. To date, NIHHIS has helped 69 communities map their heat islands and has built a community of practice to help those communities learn from one another of how to reduce heat risk. NIHHIS was jointly created and jointly run with the Center for Disease Control and Prevention. Through NIHHIS, NOAA and CDC partnered together to develop new integrated heat and health tools. In the Southern Plains, NIHHIS has mapped heat islands in Austin, Houston, El Paso, Albuquerque, and Las Cruces. These communities apply this information to reduce heat risk. For example, Houston included the mapping campaign in its Resilient Houston Plan, where it is used as input to determine where action to reduce heat risk is greatly needed. In addition to heat and drought, we're also seeing elevated risk of wildfires right now. Drought and persistent heat set the stage for extraordinary wildfire seasons in recent years, underlying the urgent need to understand and better predict the extent and intensity of future fires. Collaborative science expertise in observations, weather modeling, decision support, and social, behavioral, and economic sciences from across NOAA will improve weather, smoke, and fire behavior forecasts. Working with federal, state, local, tribal, and academic partners, NOAA is advancing tactical firefighting decisions, improving risk management and resource planning, and increasing an understanding of impacts of these fires on human health. In addition, this work will advance satellite-based products for fire detection. Near continuous satellite observations for fire intensity help predict rapid changes in fire behaviors. These nowcasts provide firefighters with critical information before and during the early stages of fire, at those critical times when intervention can change the outcome. Ultimately, NOAA will tap into world-leading archives of historical weather and environmental data, together with modern AI techniques to predict wildfire risk and burn behavior from weather forecasts and land cover information. A new fire weather testbed will also investigate fire manager needs, improve forecast delivery, and ensure fire danger information is part of the improved forecast plan. It will take all of us working together to develop these solutions to drought and extreme heat and wildfire. Thank you for joining us today.
Thank you. I'd like to thank Dr. Kapnick for sharing those remarks with us today. And now I'm going to turn a little bit of time over to Julie Turton, the Director of the National Integrated Heat Health Information System. So go ahead, Julie.
Thank you, Joel, and thank you everyone for showing up today. So I'm Julie Turton, and I lead the health activities for NOAA, and I am the Director of the National Integrated Heat Health Information System, along with my colleague from the Weather Service and from the Centers for Disease Control. But NIHIS is also a very active interagency group, and we were created in 2015 under the auspices of the National Security Council, because they recognized that heat was a really huge issue across all the infrastructure, and that health was one of the primary pieces that fell between the cracks. So NIHIS was created to address heat, not only improving what we do during a heat wave, but recognizing that there was a lot going on already that wasn't well coordinated and well synergized across federal, state, local, and tribal communities. And also that we were really going to have to address heat on multiple timescales, not just during an event, because we knew we were going to be having more and more heat waves. And in fact, we're really pleased to be doing this with NIDIS today. We didn't plan it quite like this, but at this moment, over a third of the nation's population is under an active heat alert, watch, or warning. You'll see later on today kind of what's coming in terms of drought and heat and the intersection, and then you add wildfire. So we're really pleased to be here and to try and tackle in a different way some of these cascading impacts and the like that we're all seeing and feeling. So NIHHIS was created, as I mentioned, and the goal is really to create a nation that's free from heat-related illness and death, period. We have the similar structure to NIHHIS, NIDIS, the National Integrated Drought Information System, so an integrated system, which means really we are driven by decision maker needs and demand. So understanding who needs what at what time scale, what decisions they're going to make with that information helps us then figure out what we need to improve in the observations and health surveillance, and what kind of prediction tools and what time scale we need to be developing things that people actually need and will use. We're obviously interested in the end game of enhancing solutions, both based on evidence and research, and co-development of tools and products that will be of service. And then in the last slide there is really, facilitating a more effective response and building resilience in the long run, not just responding to a heat wave. A couple of things that are underway right now. First of all, between yesterday and today, you might have seen the Biden-Harris administration make some announcements with regard to heat, and really freeing up and making available some resources to supplement cooling costs and to promote building heat resilient building in the long run. And there are a whole suite of resources coming, including from NIHHIS and regarding heat and a federal approach to that in the next week. So, stay tuned. There's some more things on the way, and you'll be hearing about those. But right now we are in the middle of a heat awareness campaign. So if you're interested or tracking and want to contribute or participate, it's #NIHHIS and #heat safety. And then we are also in the middle of our urban heat island mapping. By the end of this summer, we will have mapped over 70 cities and communities. This year, we are doing 14, including 2 international cities with some partners, which we're really excited about because there's a lot we can learn from other countries as well. So without further ado, I'm really pleased to have a presence here with you all on this webinar, and looking forward to hearing the rest of the presentations. We're going to learn a lot about what's coming in terms of drought and heat, and we have some speakers from our federal family on some new tools and products that really put heat and drought in a health context for you. So Joel, thank you for a few minutes, and thank you again to the participants for being here, and we're looking forward to the rest of the afternoon.
And thank you, Julie. We really appreciate the partnership that exists between our 2 programs. And now I'm going to give a quick explainer about NIDIS and why we with NIHHIS are hosting webinars like this one for the Southern Plains. And we held one earlier today for the West, focused on the Western drought. NIDIS was established by Congress in 2006 by public law, and it was reauthorized twice with strong bipartisan support in 2014 and 2019. Our mission is the following. I'm just going to read this. So, to develop and provide a national drought early warning system, to coordinate and integrate federal research in support of drought early warning, and to build upon existing forecasts and assessment programs and partnerships. So a large part of NIDIS's mission is accomplished in hosting webinars like this in partnership with NIHHIS. The most recent drought in the Southern Plains began in around September of 2021. It worsened over the winter months. And despite some rain over the recent months, severe to exceptional drought remains in the region. In addition, much of the Southern Plains region from Kansas down to the Gulf Coast has experienced a series of intense heat waves already this summer. These heat waves, in combination with high evaporation and low rainfall, has caused some very rapidly intensifying drought conditions across the Southern Plains, making webinars like this even more timely. This 2022 Southern Plains Drought and Heat webinar has assembled stakeholders, decision makers, and drought experts from around the country. This is an informational webinar on the drought and heat conditions across the Southern Plains. And this webinar will include a summary of past, current, and forecast drought conditions and the ongoing impacts of drought and intense heat across the communities and sectors in the Southern Plains. We intend for this information to be useful and timely and actionable in supporting communities and sectors that are impacted by the ongoing drought. And so following this webinar, we have just a few short survey questions of, like, what did you think, and did this webinar help you? Please just take 2 minutes to do that at the end. Thank you for that. The first session of our meeting today will be focused on drought, heat, and fire conditions, both observed and forecast outlooks. We will hear first from Victor Murphy from the National Weather Service's Southern Region headquarters, followed by Mr. John Gottschalk from the Climate Prediction Center at NOAA's National Weather Service. We'll then hear from Jenny Kerouac from the U.S. Department of Health and Human Services about the current heat and human services, current heat and the trends and the impacts of the heat on health. And then the final presenter of this session will be Dr. Nick Nosler from the Department of Interior's Bureau of Land Management and the National Interagency Fire Center, or NIHHIS, about summer wildfire conditions. Following these 4 speakers, we'll have just a few minutes for questions for the speakers. Please feel free to put your questions into the question box as we go along. We won't have time to get at everybody's questions. We'll pull out a few that we think are really interesting, and then we'll just read those to the panelists and give them a chance to answer. But now we'll turn over to the presentations. We're going to start with Victor Murphy. I'm just going to quickly introduce him. I'm really happy to be able to introduce Victor at this webinar today. Victor is the Climate Services Program Manager for NOAA's National Weather Service Southern Region, which includes the states of Texas, Oklahoma, and New Mexico. He routinely participates in drought monitoring and issuance of climate products from various National Weather Service forecast offices across these 3 states. Thank you very much for being here, Victor. I'm going to turn it over to you.
Okay, thank you, Joel. As Joel mentioned, I work for the National Weather Service Southern Region headquarters in Fort Worth, Texas. I'm the Climate Service Program Manager there. And next slide, please. Okay, as Dr. Kapnick mentioned, 93% of the Southern Plains DEWS area, drought early warning system area, is in drought right now. 78% of the area is in severe drought or worse. And look at the graph there. I think the amount of the area in severe drought jumped from like 65% to 78% in the past week. I think a lot of that is due to the presence of flash drought, which has developed across a lot of Oklahoma, and some of our future speakers will speak towards that. Next slide. So I'll do a quick tour of the region here, and we'll start off in New Mexico. New Mexico is actually one of the few areas that's seeing some improvement here since the start of June. 33% of New Mexico right now is an extreme or worse drought, which is the lighter red color there. On the right, you can see how New Mexico was doing on April 19th. And then on the slide on the left shows the most recent one. So they have improved. Basically 2/3 of the state was an extreme drought or worse 3 months ago. Now it's down to about 33%. And the big factor there is the onset of the summer monsoon. They had both Arizona and New Mexico had a big burst of monsoonal rainfall, which started about June 16th, I believe. And it lasted about 2 weeks, maybe into perhaps 4th of July weekend or so. It has diminished a little bit since then, unfortunately, but that was the reason behind the big improvements there in New Mexico. Next slide. And so you can see here on this graph, since mid-June, New Mexico has seen about 200%, or actually just slightly more than 200% of the normal rainfall. Certain parts of the state have seen in excess of 400, 500%. I believe Santa Fe has seen over 5 inches or so, which is, I believe, their wettest start of the summer so far on record. So that's a good news there. The monsoon has delivered so far this summer. Very important for New Mexico. They get about 50% of their yearly rainfall, or yearly precipitation, I should say, from the summer monsoons. Next slide. Yeah, there you go. There you can see that statewide, the June average rainfall for New Mexico was 2.5 inches. That's a statewide average, which is about actually a little bit more than 200% of normal, and it's their wettest since 1986. So, certainly a good start for New Mexico as far as summer monsoon goes. Hopefully, they can keep that going. Next slide. Okay, so despite the good news short term for New Mexico, longer term, New Mexico is still on the eastern fringes of that, 20-year long mega drought that's persisted across California, Arizona, and the western U.S. New Mexico is sort of on the eastern fringe of that. This chart here, going from left to right, shows the various different time scales, and you can see that New Mexico has had a lot of different periods here with extreme drought, which is the red, and actually even exceptional drought, which is a bright red, over the past 20 years or so. This graph here starts in 2000 with the advent of the drought monitor, and on the far right-hand side, you can see where they're at currently. So New Mexico has seen a lot of drought over the last 20 years or so, and any improvements they've seen in the last month is just so far just really, really very short-lived. And I think longer term, the longer term things will probably not improve a heck of a whole lot, but let's see what the rest of the monsoon has. Next slide. Okay, some of the impacts for New Mexico. The monsoon came not a day too soon for them. The early start, a relatively early start of June 15th or 16th, much appreciated. Prior to that, we've got records from the Government Area Coordination Center, which is a Forest Service agency, and they've had records. We've got good accurate records from them since 1990. And New Mexico's had their number 1 and number 2 largest wildfires on record this year. The Calf Canyon complex, just northwest of Las Vegas, New Mexico, had 342,000 acres burned. The Black Fire had 325,000 acres burned. Previous record was 295,000 roughly for context. So that certainly shows the impacts there. And statewide, they've had 899,000 acres burned so far, which is about 350% of their historical average of 270,000 acres. So major impacts there. Next slide. So I also want to talk about the reservoirs. So the largest reservoir is Elephant Butte. It's in the southern part of the state. It's at 5.5% of capacity. You can see in the bottom right there, it's tracking, the top graph there, it's tracking very near historical lows. And you can see on the bottom slide there, it's been less than 50% of capacity since about 2000 or so, really when this mega drought began. And of course, Elephant Butte's a rather complex reservoir. Texas is, by compact, Texas gets a certain amount of water from it, I believe, as does perhaps Mexico. So not good. It hasn't been good for a while, though. And you can see that, this is what long-term drought looks like, folks. Next slide. So we'll take a quick peek of Kansas. Kansas actually, relatively speaking, is much less, worse off than the rest of the Southern Plains. 23% of the state right now is in extreme drought, which is D3 or worse. That is the most since 2018, but as you can see from the slide here, the 3-year period there from 2011 through 2014 was much more prevalent as far as, the red and bright red, the extreme drought and exceptional drought goes. Next slide. Biggest impact so far in Kansas have been actually a heat stress event. I guess had a relatively mild spring, April, May, then a sudden, warm up heat event. Nighttime temperatures didn't cool off a whole lot, and they had over 2,000 cattle killed in about a 1 night or 2 night period there on June 11th through June 12th. Basically, from the cattle not being able to cool off at night. Maybe the fact that it was the first heat event of the summer may have had an impact, but that's pretty significant there. Next slide. So working our way south into Oklahoma. Oklahoma's been a tale of 2 droughts. From January 25th through June 28th, well, on January 25th, at the start of the year, Oklahoma had 78% of the state in severe drought or worse after a very robust May and early June wet season, which is supposed to happen. And everyone was thinking, quite honestly, Oklahoma was out of the woods. The tide had turned. The severe drought of the winter and early spring was, about to give way or disappear. And then all of a sudden, mid-June hit, late June hit, and we went flash drought struck. And within 3 weeks' time, Oklahoma went from 15% of the state in severe drought or worse on June 28th to today's drought monitor, and they're at 58% of severe drought, right back where they started pretty much. And I would expect next week's value should probably increase some. Next slide. So you can see the culprit there. This is the 30-day rainfall from the Oklahoma Mesonet. You can see the southeastern 2/3 of the state seeing less than a ½ inch of rainfall. The white areas there are basically areas of zero precip, so zero rainfall over 30 days time. Toss in some temperatures of 100 degrees plus for several days, certainly not good. Next slide. And July 19th, at least so far, was probably the epitome of the flash drought across Oklahoma. These are the maximum temperatures that were recorded that day across Oklahoma. Every one of the Oklahoma Mesonet stations reported at least 103 degrees on that day. The statewide average max temperature was 109.2. That's the third hottest daily average temperature there since the inception of the Mesonet back in 1994. I believe a couple of days in August of 2011, August 1st and August 2nd were slightly warmer, like 109.9, I believe. So there you can see, what 30 days without precip contributes to, or what if you have 30-day period without precip, you can see, tossing in these kind of max temps certainly exacerbates the situation. Next slide. And so, for example, you can see here Oklahoma City. As of today, today is our 40th. As of yesterday, had 40 consecutive days without measurable rainfall. That's 14th longest such streak on record, and pretty interesting the fact that their second longest streak on record occurred November through December of 2021. You can see number 2 there is a 57-day stretch from which ended on December 30th of 2021. So a 57-day stretch with no precip ending December 30th. That accounts for the fact that their drought situation is so horrible in early part of 2022. There's some good precip coming in May and June, and now right back to where we started again. So you can see an amazing amount of weather whiplash there, if you will, going from one extreme to the other, right back to the first extreme again. And I think this is one of the big challenges facing all of us in the weather and climate community. The 2 slides here on the right, you can see the 40-day total precip, Oklahoma City from June 10th through July 20th. 40-day rainfall, a trace, driest such period ever. On the right-hand side, also on the bottom, is the average max temperatures. You can see the average max temps have been exactly 100.0 for a 40-day period, for a 20-day period, the month of July. And that's the 7th warmest July so far for max temps. So near zero precip or non-measurable precip for 40 days, 7th warmest July temps on record, averaging triple digits. Obviously, you can see the perils there. Next slide.
Victor, I'm going to give you just one more minute to finish up.
Sure. Okay, so this is a classic definition of flash drought. You can see there where this is a change in drought categories for the last 4 weeks. You can see a lot of 2 category, 3 category changes there across Oklahoma, which by definition, flash drought is pretty much a 2 category change in the drought monitor over a 4-year period, a 4-week period. Next slide. Okay, impacts, major cattle sell-offs, hay yields have been down. Winter wheat crop was down 44% from last year. The yield was down 33%. Next slide. So work our way down to Texas. Texas pretty much went from bad to worse. We've had 12% of the state in D3 or D4 since the start of the year. We're now at 18%. We've had at least 10% of Texas in D3 or D4 drought every week of the drought monitor since September of 2020, about a 2-year period almost. Next slide. So the impacts, 12,000 acres burned in the last week. You can see where the larger fires are there. Next slide. Power grid demand. Texas has broken its demand record for power 11 times this year. Yesterday, we set a new all-time record of above 80,000 megawatts of power demand. At the start of the year, the Electrical Reliability Council of Texas, which sort of runs the Texas power grid, expected a 5% chance of us exceeding 80,000 megawatts. We've already done it. We're only halfway through summer. Next slide. Okay, losses. You can see the 2011 drought, we had agricultural losses of $7.5 billion. There's been all kinds of reports lately of big sell-offs of cattle. There's no doubt in my mind that this would be another $1 billion climate disaster once Adam Smith and the folks at NCEI assess this thing. Oh, by the way, DFW now has 47 consecutive days with non-measurable precip. Next slide. And you can see our April through June period was the hottest on record by about 4.5 degrees, actually hotter than 2011. Next slide. Okay, what's sort of causing this real quick? You can see the big, huge ridge has been centered over Texas all summer long. That accounts for the heat. Let's look at the height anomalies. This tells us the difference from normal. And next slide. And you can see the anomalies on the left is from June 1 through July 17th. On the right is for the month of July. You can see basically big positive anomalies over the southern plains and the central plains, which seem to be shifting northward actually here during July, so it doesn't bode well for the northern plains. And you can see a big, huge monstrous trough off the Pacific Northwest, which has probably been the big blocking pattern or the big block as far as keeping this very stagnant pattern in place. Next slide. And here's a 38% of normal rainfall. You can sort of see underneath that big ridge the lack of rainfall. The reds there are less than 25% of normal. Next slide. And I think that's all I have. Thank you.
Oh, thank you very much, Victor. We'll next hear from John Gottschalk, the Chief of Operations of the Operational Prediction Branch at the Climate Prediction Center within NOAA's National Weather Service, where he's responsible for a suite of subseasonal to seasonal climate outlooks and monitoring products. Prior to his current role, he served as the Climate Prediction Center's head of forecast operations. Over to you, John.
Thank you very much, Joel. Appreciate the invite to present today. As Joel mentioned, I'll be providing a look ahead with some of our outlooks from the shorter range predictions, week 2, all the way out to what we expect during the month of August and to the August, September, October period, as well as the outlooks with respect to drought, and further looking at with respect to any evolution with respect to Enso. Next slide, please. So this particular slide focuses on the days through 8 through 14 period, but I did want to make a note of the first few days, the last few days of July before this period starts, is that as many folks know in the Southern Plains, it looks like there'll be another extensive period of 5 days or so of extreme heat and with little precipitation that's going to further exacerbate some of the flash drought development that Victor was talking about. Did a very good job of summarizing that from Kansas, Missouri, Oklahoma, Texas, that we've had over the last 2 to 4 weeks. That's likely to further worsen over the next 5-7 days. But there is some light at the tunnel in the sense that there may be a transient break. What's shown here are the days 8 through 14 temperature outlook on the left and the precipitation outlook on the right. It does appear that there will be a front boundary that will be sinking across through the plains. There's quite a bit of uncertainty as to how far south that boundary will go, depending on the various model predictions that we have at our disposal. But we do feel that will be favoring above normal precipitation for a time from mainly the 6 to 10 day period and slightly thereafter into the 8 to 14 day period across parts of the Southern Plains. The probability shift from normal is not particularly strong, but it is in the right direction. Temperature-wise, they're still favored to be above normal, as can be seen on the left-hand plot. But these probabilities, as you will know, are considerably lower than what we've had over the last few weeks. We can go to the next slide, please. So with respect to the U.S. hazards outlook, which focuses more on the tails of the distribution or the extremes, what's shown here on the left-hand side is the risk of temperatures, the calibrated odds or probabilities from model predictions and tools that the upper 10% of the historical range will be realized. And over the past last couple of weeks, we've had many instances where the high risk or the darker contoured line had been over the central plains. It does look like during the week 2 period, the slight risk, which is the outer contour that's crossing the central part of the country on the figure on the left, is going to be shifted further to the south, and the moderate risk is going to be confined to parts of East Texas and Louisiana. So that's also a good sign, at least in the short term. We do think this change in pattern is likely to be transient. It's unclear whether it will last longer than just the period indicated. But we'll have to wait and see on that moving forward. If we go to the next slide, please. As we move into the week 2, more specifics about this. This is a combination of model guidance, which shows on the left-hand side that the heading should be the probability of the heat index or temperature being greater than 110, not 105. So the main source of concern will remain pretty far south than where it has been, say in where it has been for Kansas and Missouri and other areas further to the north, to more towards eastern Texas and Louisiana. So as you see with the darker red shades, higher probabilities for exceeding those thresholds. There is a higher tongue that does move further to the north, where one of the model guidance products has still considerable uncertainty with how far south that boundary of cooler, wetter conditions moves to the south. The plot on the right is the actual temperature, the max one day during the week 2 period of either a dry bulb temperature or heat index. And you can see the areas in the southern plains, the eastern areas of the southern plains are ranging from 105 to as much as potentially 110 with heat index values across, again, parts of East Texas and Louisiana. So that's kind of the thinking right now over the next 14 days or so. Next slide, please. So with respect, this forecast will be updated tomorrow. This is issued once per week, but this was the week 3 and 4 forecast for the period almost the first couple of weeks of August. Temperatures still favored to be above normal. Don't expect too much change in that area. With respect to the precipitation outlook on the right, are favoring below normal below normal precipitation across the southern plains. This is a 2-week outlook, not just the 1 week, but it may be more likely to be near normal with that boundary that I've been discussing in the period. So we'll update this outlook tomorrow to see if any changes. Next slide, please. So as we move into the longer lead outlooks for the month of August, favoring above normal temperatures for much of the country, then basically the entire CONUS region. The highest odds, unfortunately, include parts of the southern plains and lower Mississippi Valley. We are favoring also below normal precipitation. Again, it's very modest odds, only a slight tilt from climatological odds for the central plains and southern plains, just greater than 40% at the max across southern Texas. For the August, September, and October period on the next slide, not too much of a change. We don't see any signals in the August, September, October period of a particularly wet pattern across the southern plains. Continuing favoring above normal temperatures with the highest odds further to the west across the western U.S., but still significant tilt in the odds towards above normal temperatures across Texas and parts of the southern plains on the western areas of the high plains. With respect to precipitation, again, favoring below normal precipitation from the central Rockies down towards the southern areas of the high plains, but equal chances in some of the other regions of the southern plains area. Next slide, please. So with taking all of the observational and forecast information into account, the August, September, October drought outlook is indicated here on the left-hand side. The areas, unfortunately, the areas in brown indicate continued persistence of drought conditions or worsening in those areas, and in the yellow areas, potentially drought development. And this is a combination of really of a number of factors across time scales. There's the enhanced likelihood of above normal temperatures, mainly through much of the period from the short range all the way through the longer range outlooks. Antecedent conditions in many areas, as we starting with respect to the rapid drought onset that we've had in many of these areas. And also the potential for extreme heat at times, as I mentioned, in the very short term, as well as below normal precipitation favored on average for most of the region. Next slide, please, Joel. And so finally, to wrap up, just what we may expect with the updated Enso forecast, we do expect La Nina conditions to continue through the calendar year 2022. There may be some decrease in the odds and some less interaction or cooling of SSTs or sea surface temperatures in the Pacific during the late summer, but we expect La Nina conditions the probabilities or the odds for La Nina to continue through the whole calendar year into the winter months, as indicated by the blue bars. The general probability for the La Nina advisory to continue, basically near 65% by the time we get into the late autumn, early winter months. Final slide, please, Joel. So just to summarize, above normal temperatures are most likely for many of the periods that I showed. Week 2 from late July into early August, with the potential for early on hazardous extreme heat in the southern plains during the last for the August and September and October periods, above normal monthly and 3-month mean temperatures are most likely, with the highest odds in August for eastern Oklahoma and Texas and West Texas for the seasonal August, September, October period. A combination of factors across time scales, again, as I mentioned, supports drought persistence or worsening, with potential drought development continuing in other areas in the southern plains, as indicated by the seasonal drought outlook. And finally, we do expect La Nina conditions are favored to remain throughout the calendar year 2022. So back to you, Joel. Thank you for your time.
Nice one. Thank you, John. Next up is Jenny Kerouac at the U.S. Department of Health and Human Services. Jenny is a policy analyst on detail with the Office of Climate Change and Health Equity from the Centers of Medicare and Medicaid Services Office of Legislation. Thank you very much, Jenny. I'm going to pass it over to you.
Thank you. Yeah, good to be here with all of you. And thank you to NOAA for all of your collaboration on the Climate and Health Outlook. Next slide. As background, the Office of Climate Change and Health Equity launched almost a year ago with the mandate to address the impact of climate change on the health of the American people. We are one of 3 mandates given to the Department of Health and Human Services by Executive Order 14008, tackling the climate crisis at home and abroad. Next slide. So in May, we launched the Climate and Health Outlook. The Outlook aims to connect climate change-related forecasts, like the ones you've been seeing, to potential health risks and offers resources for mitigation. Our audience for the Outlook includes both public health practitioners seeking a one-stop shop for climate health hazards and members of the media and public who are looking to be informed. Next. I do want to acknowledge that we are not the first to attempt something like this. In many ways, we're following the model of the Caribbean Health Bulletin, which just celebrated its 5th anniversary. Next. So the Outlook is a collaborative effort at every stage. We've incorporated forecasts from the National Interagency Fire Center and several NOAA centers, including NIDIS, NIHHIS, the National Hurricane Center, the National Weather Service Climate Prediction Center, and many more. We also incorporated data and analytics support from the CDC, FEMA, ARC, and others. And what I want to say here is that we'd love to hear from any and all of you about the content in this Outlook and what you'd like to see in future Outlooks, so we can continue to iterate and improve on this product. Next. Oh yeah, all of our collaborators. So here's the first page of the July Outlook, which is our 3rd ever edition. I should have said, I think I said this early on, this launched very recently and we are still iterating. So the first 2 Outlooks were focused just on extreme heat and its health effects, but this edition from July includes other hazards, hurricanes, drought, and wildfire. Page 1 shows a map of the National Climate Assessment regions with region-specific information. The goal is to visualize how climate change is affecting different parts of the country concurrently. So this page unpacks 6 of the 10 regions, and you can see the Southern Great Plains kind of blown up on the side there, but the forecasts for every region are on our website. Next slide. So here we see a side-by-side of page 1 of the PDF and the web version. The blue button that's boxed in red there takes you to the PDF. So in creating the PDF, we couldn't fit everything and still have it look appealing. So we made some strategic decisions about what to include online and what to emphasize in the PDF. In general, we see the PDF as something the general public and media may use to succinctly understand major upcoming climate health threats, whereas the web version contains a repository of information that may be more of use to practitioners. Next. So I'm going to briefly take you through our thinking in creating the 2 heat-specific pages of the Outlook. This is similar to how we've approached hurricanes and how we plan to approach other hazards like wildfire and drought in future iterations. You can see in the upper left-hand corner there that we have a map showing the expected number of extremely hot days in July in each county in the contiguous US. This forecast is based on the NOAA Climate Prediction Center's probabilistic outlook of temperatures. In total, 467 counties across 31 states were estimated to have more than 5 extremely hot days in July. And on the right, we have information about the over 51 million people who live in those counties. So one metric that struck us was that 49% of counties are in the top quartile for the number of uninsured children proportionate to their population. So here we're kind of calling out the ways that those counties have populations that may be at increased risk from the hazard we're talking about, in this case, heat. Next. On the second heat page, we start with the historic spotlight that I'll talk more about in a minute, but we also have the forecast itself from the North American Multi-Model Ensemble and include contextualization of how that forecast compares to last year's. And we also have resources on the bottom of this page. In the PDF, we stick with more actionable resources for the general public, like LIHEAP. Next. But then there are more resources available on the web. So this is from the website, and this is best practices for emergency managers and other callouts. In addition, the website has some evergreen content, like information on the 2021 heat dome and a rural health equity spotlight. As we create more deep dives on different hazards like drought and wildfire, we anticipate the PDF will stay around the same size. Right now it's 5 pages, and additional resources and evergreen information will always be available on our website. Last month, the heat dome information was featured in the PDF as our historic spotlight, but this month we tried something new. Next. Now that we're halfway through summer, we wanted to make sure that we're reviewing how the season actually played out in addition to sharing forecasts and resources. So we added this look back of how May and June 2022 compared to the previous years in terms of heat-related emergency department visits. What we found was that 2022 was generally worse than previous years. However, you can see that in Region 10, which experienced the heat dome last year, the average rates are lower this year. We hope to do our mid or post-season retrospectives for other hazards as well as we build out more hazards in the Outlook. Next. So key takeaways for the Southern Plains, and this is what we have on our website and on that first page I began with, but I also want to come back to this here. So unlike my colleagues who just spoke, this is not for August, this is for July, but I kind of wanted to show you the information that we're giving right now in the Outlook. So counties in Texas, Kansas, Oklahoma, and New Mexico are projected to have more than 5 heat exceedance days in July. And existing moderate to exceptional drought is expected to persist and slightly expand with the exception of along the western Gulf Coast. Above normal wildland fire potential is projected for northern and central Texas and western Oklahoma. Next. So I just wanted to flag there's more to come. The next Climate and Health Outlook will feature drought and wildfire as our callouts, the same way that heat and hurricane were unpacked in the current Outlook. And you can subscribe to OCHI for alerts on the updates that are going to be coming out. And I also wanted to flag that there will be an updated government-wide heat information site coming soon. Next. So I just want to end by acknowledging the amazing partners who contributed to our work. Next. And also, thank you for listening. And I do want to gather any of your thoughts on how we can improve. Please email OCHI if you'd like to reach out and discuss the Outlook or anything else. Thank you.
And thank you very much, Jenny. I'd like to point out that we've dropped the link to OCHI in the chat panel if anybody wanted to just follow that link and go and check out those resources. For the final talk of this session, we're going to pass some time over to Dr. Nick Nosler. He is a predictive services meteorologist at the National Interagency Fire Center for the Department of the Interior's Bureau of Land Management. We usually just say NIFC. Thank you very much, Nick. I'm going to pass it over to you.
All right, thank you, Joel. Yeah, so I'll be discussing the monthly seasonal outlook that we have for significant fire potential for the Southern Plains and kind of some surrounding areas for the next few months. Next slide, please. I wanted to take a snapshot of what we're looking at kind of for your guys' general area. We have several large wildfires in Texas and Oklahoma currently burning actively. We've had new ones over the last week or two, as you guys have seen in the talks leading into mine. Very dry period, very hot as well too, and that's usually a pretty good recipe to start getting wildfires, even in the middle of summer when it's supposed to be more of the convective season for parts of the Southern Plains. Year to date, more than 1.1 million acres have burned across the southern area, which is essentially Oklahoma and Texas, and then all the way across the southeast to the Atlantic coast. And most of those acres have burned in Oklahoma and Texas. Recent activity, like I said, has been driven by the record-setting heat and dry conditions. I believe it was Victor that mentioned we thought Oklahoma and maybe parts of Texas were out of the woods, and then over the last month they're right back into it and kind of being busy at the same time that we're typically more busy out west. Next slide. So this is a little bit dated. The new one came out today, but I put this together yesterday. And the reason I put the national map out there rather than just the Southern Plains is, you know, when we're creating these outlooks, we're looking at a very national scale. We have individuals that put together the outlooks from the different geographic areas, but it really impacts of what's happening in Oregon does impact what's happening in, you know, South Texas. There's only so many firefighting resources, and based on our forecasts, whether in the short term or in the longer term, like you'll see here in a little bit, it really matters what's going on. And one thing that I always try to hit on for these is drought does not always necessarily mean wildfire risk. In some areas, especially in the Southern Plains, a dry year followed, or a wet year followed by a dry year tends to be the big years because you need the grasses to grow and the shrubs to grow to have those continuous fuels, continuous vegetation to really fuel large fire growth. And we've seen that in some parts. And now with the long-term drought, we're seeing more of the larger fuels, the timber and the larger shrubs and bushes be involved in a lot of the fire activity. Next slide. John also kind of stole my thunder a little bit here, but I figured that was going to happen. But looking at the next 8 to 14 days, you know, it's supposed to stay warm and dry across the Southern Plains. There is some hope, as John mentioned, a pattern change, but there's still some uncertainty on how far south that boundary will sag and provide chances of thunderstorms and above normal precipitation. Right now, we're focusing on persistence and at least for the next week, staying hot, dry, with increased potential for significant fires across the Southern Plains. Next slide. Same thing with the drought outlook. This has changed a little bit. Persistence and development is likely across a good part of the Southern Plains, with the monsoon likely to start focusing a little bit farther to the west. New Mexico may not see as much relief as previously thought, but with the Southern Plains likely staying in drought with some expansion likely as well. Next slide. So to our significant fire potential outlooks, brief explainer here. If you see red, that means above normal significant fire potential. Green is below, and no color means near normal. What is a significant fire? It's any large fire that requires resources, firefighting resources, that is outside the immediate area to help manage and or suppress. And this is based on climatology. So it's for these particular, you see these different geographic areas or these little polygons. We do climatology in terms of fire activity for this time of year and say, based on our forecasts of looking at drought, looking at the climate prediction outlooks, our own teleconnection intel that we have, fuels and fire danger, and putting all that together to say, are we going to see above normal significant fire potential or below normal? And the reason we keep it at potential and not activity is this far out in advance. We can do a pretty good job for potential, but a lot of it, realizing that potential, depends on critical fire weather events, which are much more difficult to forecast weeks or months in advance. So for July, not a whole lot of reprieve was forecast for you guys, and I think we did a pretty good job. Probably could have even expanded it into central and eastern Oklahoma, but we've seen well above normal significant fire activity across the southern plains, especially kind of central into North Texas, Northwest Texas, and even western Oklahoma. Next slide. For August, above normal significant fire potential is essentially across much of your guys' area. I wouldn't be surprised if we see an extension with our outlook coming out here in about 11 days on August 1st, in more of Texas and maybe even more all the way through Oklahoma. But it is not looking like it will let up anytime soon. And the warm and dry conditions, or hot and dry conditions that are forecast, are just going to continue to fuel significant fire potential throughout, with occasional breaks, but the overall pattern is really lending itself to above average potential. Next slide. And then finally, or not finally in September, because we'll have one more in October after this, continuation of the significant fire potential. Start to see some of your neighboring areas in kind of the Ozarks and Mississippi and Missouri valleys start to have above normal potential. Starting to see that with some of the Climate Prediction Center outlooks, but we will be taking another look here over the next week. And you can see out west, should be above normal significant fire potential across much of the West Coast and in parts of Western and Northern Great Basin, and even in parts of Northern and the Central Plains due to those forecast warm and dry conditions. And out west, concern with lightning ignitions on the edge of the monsoon. Next slide. Finally, in October, it's going to roll into a busy fall fire season for the Southern Plains. Really no break. We saw this a little bit back in 2020, but we do think that the summer will stay active, and then moving back into more of the traditional fire season, or at least one of the traditional fire seasons, if you can say that, for the Southern Plains, kind of fall, winter into early spring. Early indications is that it's going to be an active start to the fall season, and more into the dormant season as well too, across the South Central U.S. and even into the Ohio Valley, and like I said, Missouri and Mississippi valleys as well too. So not a whole lot of optimism for you guys to slow down in your neck of the woods. But like I said, it can always change. And as you guys well know, forecasting 3 to 4 months out can sometimes be a fool's errand. Next slide. So overall, high risk significant fire potential for much of the Southern Plains for at least the next week, with those hot, dry, and unstable and occasionally breezy conditions. And then above normal potential is expected into the fall across the Southern Plains. But the one caveat I always say is there's potential, but critical fire weather events play an integral role in realizing that potential, which we often see. End of report.
Thank you very much, Nick. I'd also like to extend my thanks to Victor and John and Jenny for you taking the time to share your thoughts and your expertise with us. We have time for 1 and maybe 2 questions, depending on how much time it takes us to answer the first question. This first question is going to go to Victor. Victor, we heard a lot of comparison, especially coming out of winter, comparison of the current drought with the infamous 2011 drought in Texas. Could you talk a little bit about that comparison? How well does this drought compare with that one a decade ago?
Yeah, that's a very good question, and sort of a $64,000 question that's been permeating across Texas for a while, and I guess may continue to permeate going forward. 2011, the dryness hit earlier. The reservoir levels in 2011 started dropping back in like April or so, pretty significantly. I think in April 2011, the reservoir levels statewide were actually above where they were in 2022, but then they had a pretty precipitous drop starting in April and May, and they dropped below where we are right now. And then basically since June 1st, 2022 has just been tracking 2011 with the statewide reservoir levels basically being about 2 percentage points higher. So I think that's a good comparison as to where we are now. Question is, in 2011, the drought persisted right on in through October and November, so the reservoir levels just kept on dropping. You'd expect that to taper off when October rolls around, which is sort of secondary wet season. So I think right now everyone's waiting with bated breath to see what happens in October, or if we get a tropical system perhaps to bring us some precip in August and September. So 2011 lasted well into the latter part of the year, last month or two, as far as the drought goes. And temperature-wise, right now we're every bit as hot as we were in 2011. Austin, San Antonio right now running hottest summer on record so far. Houston's number 2 so far, hottest, behind 1980, which is another monster summer. And DFW right now is running 3rd hottest behind 2011 and 1980. So I think temperature-wise, we're right there.
Oh, well, that's not great news, but thanks for explaining that. I think to get us back on time, we're going to move on to the next session of today's webinar. To start off this session, we'll hear from Brad Rippey. Wait, sorry, I'm skipped. I lost my place on the little agenda I'm following. So when we put together the program for today's webinar, we wanted to think a little bit bigger than just here and now and larger than the Southern Plains. We wanted to look we wanted to look at what ripples this drought is having across the economy nationally and globally. So to start off this session, we're going to give some time to Brad Rippey, an agricultural meteorologist at the U.S. Department of Agriculture's Office of Chief Economist and the managing editor of the weekly Weather and Crop Bulletin. He's also an author of the weekly U.S. Drought Monitor and the monthly North American Drought Monitor. I'm going to pass it over to you, Brad. Thank you very much.
All right, thank you, Joel. I'm trying to get my camera on here. Give me just a second. Oh, there we go. Everything good?
Yes, you're good to go.
All right, perfect. Thank you, Joel. And I'll jump right in. Here's my my contact information slide. So after you leave that up for a second or two, you can move right on. All right. I know I'm going to eventually be talking about the bigger picture, but I'm going to start on the Southern Plains like everybody else. This is a region that is no stranger to historic drought. All you have to do is look back to, say, the 1930s, Dust Bowl era, nation-altering type of drought, and then again the 1950s. And this was a hard-hit region during those two times. Nevertheless, looking at the last 2 decades, nobody can deny the fact that we have seen an incredible period of ups and downs, extreme weather and climate events over this 2+ decade period going back to the early 2000s. Now, during just the 21st century, we have seen these frequent and severe droughts across the southern Great Plains, resulting in many poor growing seasons for important crops like winter wheat and cotton. And honestly, it's changed the approach to managing cattle operations. And so just to give a couple of examples, there's less opportunities for fall grazing on winter wheat. There's more requirement for supplemental feed during times of drought. Just efforts to keep animals cool, as we heard from earlier speakers about what happened in Kansas back in June. And if you look at the history of the U.S. Drought Monitor, which goes back ironically about those 22, 23 years back to 1999, I'm counting about 11 droughts in that time period, about 1 drought every 2 years on average. Although some might argue in the middle of that chart that that whole 2011 to 2014 was one continuum, one significant drought that lasted through a multi-year period. Next slide, please. Since we're in the middle of the drought of 2021-22, I wanted to step back that decade to 2011. We have a good retrospective on that. And in terms of cattle operations during that 2011 drought, this chart has a bunch of layers of data on there. Number one, cattle inventory areas in the United States, major and minor production areas in green and dark green and light green respectively. The drought at the end of 2011, coverage in the shaded red. And then finally, there's a bunch of yellow numbers on the chart. That shows year over year from the beginning of 2011 to the end of 2011, beef cow inventory change. So you can see the profound impact of the drought of 2011 on cattle operations in the United States. Look at your big drought states, Texas, Oklahoma, New Mexico, all had double-digit declines in cattle inventory, beef cow inventory during that 2011 drought, just in 1 year period. Where did those animals go? Well, some may have been sent to slaughter a little bit early, but many, like what we're seeing unfold right now in Texas and Oklahoma, went to auction. So as our USDA livestock analyst sometimes says, cattle on wheels, they ended up being driven northward to where there were literally greener pastures. So we saw 8% increases, for example, in Nebraska and Iowa. So this can have a national impact, droughts like this, especially when it's focused in one area. We've got other areas that are doing better. So really interesting post-event analysis here on cattle operations in the US. Next slide, please. Another thing that's happened during the last couple of decades is that the federal response to drought for livestock producers has improved. Now, cattle producers, livestock producers don't have the same general safety nets that row crop producers have, where row crop producers can get insurance quite readily. Really, they don't have a safety net in livestock world. And so starting only a few years after the Drought Monitor made its debut in 1999, we started seeing the federal government using the Drought Monitor, indexing the Drought Monitor to disaster assistance. The first time we saw that was during the drought of 2002-2003, and starting in 2003, non-fat dry milk, which can be an important nutritional supplement for livestock, was delivered to the hardest hit drought areas. We saw a repeat in 2006 where we saw some money going to drought-stricken livestock producers, mainly across the Great Plains. But then finally, starting in 2008, and now enshrined into law with the Farm Bill of 2008 and each subsequent Farm Bill, there are direct disaster payouts tied to the Drought Monitor that are given to livestock producers. The main program is the Livestock Forage Disaster Program, known as LFP. Next slide, please. Over the history of LFP, we have seen almost $9 billion paid out. These are direct payments, they're not loans, direct payments to livestock producers. This is a little bit outdated information. The numbers are slow to trickle in, so still being tabulated for 2021. But suffice to say, about $9 billion going out. You can see the arc of the payouts peaking during the historic drought of 2012, dropping off, bottoming out in 2019 when there was virtually no drought across the United States. We had only a couple % of the country in drought at the low point, but now heading back up. Next slide, please. Partly because of where the droughts have been and partly because of the concentration of livestock operations, Oklahoma and Texas have dominated LFP payouts, accounting for more than a third of the total payouts, $3.25 billion through the latest available information. You can see the drought of 2011 through 14 as that large spike in the disaster payouts there. Expect to see another one here as we get the data coming in from 2022. Next slide, please. Here's a national map showing those same LFP payouts, Texas and Oklahoma running neck and neck, 1.64 billion going out the door to Texas livestock producers, 1.61 billion to Oklahoma, Kansas a distant third at 630 million, New Mexico registering fairly high on the overall list at $320 million between 2008, beginning of the LFP program, and the end of 2021. Next slide. Real quickly to finish off here, just want to talk a little bit about commodity prices. It's a mess. There's a reason I'm a meteorologist, not an economist, because economy is just terrible to try to sort out. You think weather and meteorology is bad. So it's a tangled mess of factors, but it does include not only supply and demand across the world, but also US and global weather and climate patterns. There's also other economic factors, geopolitical instability. I've just thrown a few of the highlights there in the margins. El Nino, La Nina, there's climate factors. Sometimes that drives weather, such as drought and flood. But then you have to think about the US as just being one producer in the entire globe. So we have got other important agricultural regions. So for example, corn and soybeans, we have the US, but we also have South America. That can also be tangled up in La Nina, El Nino type of episodes. So very complex situation. Then you throw in COVID, which I didn't even put on here, supply chain issues, and geopolitical instability like the Ukraine-Russia situation, and it's a real mess. Last two slides will show that here are cattle prices, which are elevated just like everything else in the world right now. You can see rolling along through 2019, 2020, cattle prices were quite low, but they started to go up in 2021. All these factors we've been talking about, weather, geopolitical instability, everything else, COVID, supply chains. We have elevated prices for cattle at this time. So if you have a cattle operation, maybe that's incentive to sell off if you've got a drought. Next slide, please. And final slide, just taking a look at some commodities that are not animals, obviously your crops. Last slide, next slide. There we go. Just a quick look at hard red winter wheat, cash price at Kansas City, cash price in Illinois for soybeans, Central Illinois for corn, pretty much the same thing. Prices were suppressed through all the way even through the early COVID days, but in 2021, things really started heading up due to all the factors I mentioned and more. And so now we have very elevated commodity prices. There's supply issues. And so as we head through 2022, we've got some of the best prices, but input costs have increased too. So that's offset by, you can get good money for your crop if you have one, but it's offset by input costs for things like fertilizer. So it will sum it up, and I'll turn it back over to Joel here.
Thank you very much for that, Brad. Thanks for sharing some of the economic impacts with us. So those are some of the numbers and data that we don't usually see very often when we're focused on weather and climate things. I like you look at most of the weather data. So thank you for that. Next up is Dr. John Nelson Gammon. Dr. Nelson Gammon is a Regents Professor of Atmospheric Sciences at Texas A&M University. He's also the Texas State climatologist and the recently appointed president of the American Association of State Climatologists. As if you weren't busy enough, John. Dr. Nelson Gammon is also, his research includes extreme rainfall, drought monitoring, climate data quality, and computer modeling. Thank you, John. Over to you.
Okay, yeah, thank you, Joel. So I'm going to talk about climate projections, and I'm going to tie things into historical observations as well as the reasons why we are projecting what we're projecting. Next slide, please. This slide and the next one features some output from a downscaling effort by the South Central Climate Adaptation Science Center, looking at model projections here of the average annual daily high temperature. And we got left and right showing a low emission scenario and a high emission scenario. Give you a little bit of background on these. First off, the low emission scenario is so low we probably don't have any chance of actually being that low. And the high emission scenario is probably so high that we don't have any chance of being that high. So it sort of puts in rough upper and lower bounds on what to expect. Also, these are changes between the period 1981 to 2005 up to 2036 to 2065, so mid-century compared to tail end of the last century. If you do the math, we're about halfway between those two periods. So in a sense, we've already experienced part of the change and are on our way to the remainder of them. In the case of temperatures, temperatures indeed in the Southern Great Plains are about 2 degrees Fahrenheit, 1 to 2 degrees Fahrenheit warmer than they were during most of the 20th century. So this projected change is consistent with what we've actually seen. Somewhere around another 2 to 3 degrees change by the middle of this century, it seems likely. That's speaking to average temperatures. Turns out that's the dominant aspect of change. There's not much change in the spread of temperatures, particularly in the summertime. But as the whole envelope of temperatures creeps warmer and warmer, that tends to imply that the extremes are going to get larger at the warm end of temperatures as well. The next slide shows that. That's basically a count of the change in the number of 100-degree days. That's a pretty good benchmark for when we go from being normal unbearable heat to unusual unbearable heat in the summertime. And the increase is rather dramatic. We're talking about several dozen number of days more with 100-degree temperatures. We're getting a taste of that, unfortunately, this year. Normal high temperatures are often in the upper 90s, particularly in Texas and Oklahoma. And now we're seeing temperatures just a few degrees warmer, which puts it over that threshold into the triple-digit temperatures, and it just stays there for days on end. As you can see, Texas and western Oklahoma, southwestern Kansas, and the lower elevation aspects of southern New Mexico are the places most vulnerable to an increase in heat. Next slide, please. In terms of drought, it sort of matters what you look at. And I'll go into the explanations of causes of drought. But first off, something relatively simple. Projections, excuse me, projections of 3 different types of indicators of moisture in the soil from climate models, going all the way back to historic runs into future projections. This is for that upper high-end climate projections, so what will actually happen is probably less extreme than this. But basically, depending upon what indicator you look at, soil conditions in West Texas and similarly in other parts of the Southern Plains will, under normal circumstances, be consistent with what they used to be considered to be a dry year. And a dry year would be consistent with what used to be considered a really dry year. So the whole range of typical conditions is getting drier for the soil, and that means droughts will be that much more severe as well for the soil and for plants and so forth. Next slide, please. So the last couple of slides are from a paper by Kate Marvel and co-authors looking at the latest CMIP-6 runs, looking at different aspects of water in the United States, including they broke it down for the Southern Great Plains here. And the colored hues indicate where the different projections, different scenarios come out showing a change that's substantial compared to what you typically have changing from year to year. And soil moisture, as seen above, both surface and total column soil moisture are projected to decrease in CMIP-6, just like they did in CMIP-5. The snowfall is also expected to decrease as temperatures get warmer, we get less snow. But some of the other indicators of the water cycle are not so clear. Precipitation down the bottom, that X means that models don't have a strong consensus on a change, and what change there is projected is kind of small compared to the variability of climate in this region. Similarly, runoff, both surface runoff and runoff plus infiltration into aquifers, is not projected to be clearly lower going forward. In fact, more than half the models actually project a slight increase in runoff. So what's going on there? Well, first off, little known change in precip, but the other fact that we looked at was increase in temperature. And higher temperatures mean greater evaporation. So even if you had the same amount of rainfall, soil moisture will decrease on average because water is getting sucked out of the soil faster than it used to be. So higher temperatures lead to more extreme agricultural drought for that reason. Another thing that the higher temperatures are doing is they're increasing the intensity of rainfall. So even if the total amount doesn't increase, the intensity of rain does. So we have rain falling in more confined periods of time and falling heavier. So that again is bad for soil moisture because there's more runoff. And that's why we don't see a significant decrease in runoff either. But runoff is kind of hard to predict in models. They're not very comprehensive in terms of how they're simulating what happens to the water after it reaches the ground. So there's not a clear, definite uptick in runoff, but there's a clear decrease in soil moisture. So water supplies, reservoirs, which depend on runoff, may not do so bad in the future, except the greater temperatures means that water will evaporate from the reservoirs faster, even if they get the same amount of inflow. So bottom line, you've got this combination of factors affecting different aspects of drought in different ways. But the bottom line is most of it's pointing toward similar or worse conditions for drought moving forward across the southern plains. Last slide shows an example of what we're seeing with the rainfall and runoff. The projection is for a slight decrease, perhaps in the South Texas. The crosshatching indicates that at least a quarter of the models say one thing and a quarter say another. So the rainfall projection is not so clear. Runoff, a lot of differential opinions from models. The majority show an increase in runoff. The strongest signal is with soil moisture decreasing. Now, we have historical observations of runoff. Stream flow has not changed much overall across the region, so that's consistent with the models. We don't have long-term measurements of soil moisture, but for the reasons that the models are driving the soil moisture decrease, scientists are fairly confident that that's something that's already taking place and unfortunately will continue in the future. Thank you.
And thank you, John. Now, when I was introducing John, I was reading your short bio, and I skipped the line that said you were also the director of the Southern Regional Climate Center. So I wanted to make sure I got that in. You're the state climatologist, president of the American Association of State Climatologists, and the director of the Southern Regional Climate Center. Thank you for sharing some of your recent research with us, John. And I'd also like to thank, once again, Brad for helping us see bigger than just the Southern Plains with this current drought. To finish up today's program, we're going to return to the Southern Plains and hear from people in the region about the current drought and heat and how it's been impacting them and their cities and their businesses and the way that they need to take care of things in life. So we'll first hear from Lisa Larocque, the Sustainability Officer for the City of Las Cruces, New Mexico, a role that she's held since August 2013. During her tenure, Lisa has focused on renewable energy, climate change, and urban heat island impacts, especially in low and moderate income neighborhoods. Lisa also supports city staff in a myriad of sustainability projects, from energy finance models to plastic bag ordinances. Over to you, Lisa. Thank you.
Hello, thank you so much. As was introduced, I am the Sustainability Officer for the City of Las Cruces, and usually I participate in webinars in my profession. So today was a very sobering look at our region. My presentation will dwarf yours in scale, but I hope it confirms that we are listening and acting locally. So next slide, please. So I am from Las Cruces, and if you didn't know where it is, it's in southern New Mexico in the Chihuahuan Desert as a mid-sized town. Next slide, please. Like all of you, we face a lot of shocks and stressors, and I need to respond to all of them in our community to influence long-range planning. Next slide, please. We have looked at our trends in our extreme heat events, and as has been said many times, the changes that are happening this century are significant, from going from 1 month to 2 months mid-century to 3 months by the end of the century, and 3 days of temperatures over 105 to 3 weeks to 6 weeks. And although all of our temperatures vary, it is a serious change. And this escalation in heat requires us to rethink our urban and infrastructure approaches. So I'm going to tell you about that today. Next slide. Victor Murphy has already talked about the New Mexico mega drought, so I won't cover that. But this does not bode well for our agricultural industry. And the season's allotment this year is only 5 inches per acre. And the city relies on groundwater, but realize that this is a really big impact for our community. Next slide, please. So there's different things that we've tried to do to mitigate these problems. 4 years ago, we created a cool corridor where we harvest stormwater to increase the tree canopy. This strategy can be a win-win. Unfortunately, tree roots and utility services under the road have caused problems, and so it hasn't been something we've been able to replicate often. Next slide, please. Las Cruces was one of the cities that participated in the NOAA Urban Heat Island campaign, and this shows a section of our inner city neighborhoods. The ambient temperatures with urban heat island has really exacerbated the extreme heat and climate predictions that we've seen already. And we overlaid our active transportation plans on top of this area because we have 14% of our residents households don't have cars. They want to examine how our ability for people to ride safely and walk safely in the neighborhoods, and have tried to prioritize our plans moving forward in that direction. Next slide, please. So as one of the forms of mitigation, we've applied a cool pavement in the bike lanes using an asphalt emulsion sealant. And this sealant has titanium dioxide that fluoresces the UV light and decreases the surface temperatures by 10 to 12 degrees and potential of ambient temperatures up to 3 degrees Fahrenheit. And the cooler surfaces reduces buckling and cracking and extends pavement life to 5 years instead of 3. So it's a situation where we have a win-win with it serving multiple concerns. Bicyclists have already reported that heat was one of the main factors why they didn't ride, and now they feel safer on the green demarcated lanes. So that's one of our strategies. Next slide, please. The problems that we have, not only do they occur in the inner city in the outside, but residents have problems in their homes. A lot of the homes were built before the 70s, and they're characterized by cinder block construction, single pane windows, poor insulation, and evaporative coolers, which are filters that pass water over them to try to cool the area, the inside of the area. But during monsoon season, when we have these extreme heat with more humidity, they really aren't effective. So from a survey, we learned that we can't count on neighbors helping other neighbors. When asked how many neighbors you could ask for help, 39 of them percent said none, and 40% said 1 to 2. So coming up with strategies for resiliency are significantly important for us. Next slide, please. And there are 4 different strategies that we're using here because we want to institutionalize change. One of them is to codify urban heat island mitigation efforts using the CAPA data that we collected, the urban heat island data that we collected, that if the average temperatures are greater than 90 degrees Fahrenheit, we are requiring that the Public Works Department incorporate cool surfaces, cool corridors, increase tree canopy to try and lessen that drain on residents when they're outside. We are codifying electric ready and green building codes to encourage any energy transition. And we're hosting an electrification expo and training in January to try and really tackle the greenhouse gases that we're seeing from the building sector. And we are also developing a residential energy map at a neighborhood level that'll provide data on gas, electricity, solar, cost burdens, shutoffs, ownership status, and benchmarking to be able to strategize who needs help first and what we can do. So we're not shooting in the dark about that, and really trying to harness those funds that we're getting from infrastructure and other grants that are out there to be able to be strategic in our approach. And lastly, we're going to use that data to facilitate an energy service provider and stakeholder meetings to develop low and moderate income resiliency strategies with lower cost burdens in the fall of 2022, with the idea that we'll run a pilot and scale up using new sources from franchise fees from the electric company and other funding sources to try and address these problems. The sustainability community really looks at how we can scale up our efforts now, because we have learned from you about all of the challenges that are before you. And if we can institutionalize change, we hope that we can make a difference. Next slide. So that's it. Thank you very much for your time. I appreciate it. And thanks for keeping us all informed.
Fantastic talk. Thank you, Lisa. I was lucky enough to visit Las Cruces earlier this summer. You have a beautiful city there, and I wish you success as you implement some of these changes you've talked about.
Thank you.
Our final speaker will be Brad Fuller. Mr. Fuller is the president and owner of Western Horizons Corporation, a marketing and risk management service for ag producers across Kansas, eastern Colorado, and the panhandles of Oklahoma and Texas. That he's been serving these communities for 34 years. In addition, Brad and his family purchased a ranch and moved to Osage County in northeast Oklahoma, moved there from southwest Kansas in 2019 so that they could expand a registered Angus operation centered on selling bulls to commercial customers. Thank you for being here with us, Brad. I'm going to let you go from here.
All right, thank you. Well, I'll get started and try to get this covered. First of all, we'll start in Kansas, and that's been a drought that's been developed, as people had mentioned earlier, and then we'll go to northeast Oklahoma, where I think it's the best example of flash drought that I've ever been a part of. The first slide, we're going to lay out how this drought's built in Kansas, particularly the western side of the state, where a lot of my clients are call home. This is the last 6 months of 2021, and you can see basically northwest Kansas was the driest district out there, but it incorporated all the way back into central Kansas. Next slide, please. Then we move into 2022, the first 6 months of 2022. These are precipitation ranks by climate district. The closer you are to 130 means the drier you are. And we were hoping for some relief as we rolled around in spring, and we never got it. So for the first 6 months of 2022, it was still pretty darn dry, with improvement as you moved east across Kansas. And then for a yearly ranking for the 12 months from July 1 to July 1, next slide. You can see that those western 3 districts in Kansas were pretty darn dry, and central Kansas is dry as well, but not nearly the extent. The impacts of this are, we have impacted crop production, and the first casualty of this was our hard red winter wheat crop. And on July 12th, WASDE's estimate on this was 267 million bushels for the state of Kansas versus 364 million last year, with an average yield of 39 bushel an acre. The last 3-year average has been just under 50 bushel an acre. So as you can see, our first casualty was our wheat crop with lower yields, and as a result, reduced profitability for our producers. Let's skip about 3 slides, and I'm going to talk about the next casualty, which is our corn crop that is under development. Skip one more. Skip one more. There we go. This was as of Monday in northwest Kansas, north of Colby, Kansas, between Colby and Atwood. These are tremendous dryland farmers up there that use a lot of no-till. I would say the slide on the bottom is toast. These are dryland cornfields. The ones on the upper still have some potential, an earlier planted field on the right and a later planted field on the left. but this was as of Monday. I think the end of the week, we're going to be writing maybe the one on the left off as well. Next slide, please. This is West Central. This is north of Scott City, Kansas, in an area up there. The two fields on the right, I would say, are already toast. The one on the left still has potential. This was as Tuesday. We've had a pretty warm week, and so you make your estimates on what, but all of this stuff is curling tightly, and some of it's beyond that and burned up. And then one more slide, please. Next one, Southwest Kansas. We've got several slides here. This is down in Johnson City area, dryland cornfields. The one on the left, I think, is toast. The one on the right still has some potential, but again, running out of time. One more slide, please. And then the last slide is a dryland field on the left versus a part of an irrigated sprinkler circle on the right. You can see the one on the right is much better with the irrigation, but the one on the left. I will tell you though, we have been hot enough and dry enough, and irrigated yields are being impacted as well. In fact, we have had crop scouts talking about how the corn has been flashing, or as another term is scalding, due to the days being too warm and the nights not cooling down enough. And just because we have irrigation doesn't mean these factors and Mother Nature can have an impact. And we need some help from Mother Nature, and she has been brutal, particularly this week. But the reason I talked about those slides earlier, setting up the year on the year-long drought in Kansas, particularly western Kansas, we had no subsoil or very limited subsoil to work with. And as a result, you get the wrong week or two of weather back to back, you can have significant yield losses. I think this last 7 to 10 days, we're having that in the state of Kansas, and the dryland corn crop, particularly in western Kansas, is going to be a pretty tidy number, and the irrigated yields are being impacted negatively as well. The Kansas crop is about 71% dryland, 29% irrigated. Like I said, the western 3 districts account for 45 to 50% of total corn acreage in the state of Kansas. So I'm told we had a concern all year from planting season on, which impacted the way guys how many inputs they put into the dryland corn across western Kansas due to the lack of moisture. But right now we had a little hope, but it's fading rapidly over the last several weeks. Let's back up a couple slides. So the next impact was, I think, a fairly substantially reduced corn crop in the state of Kansas. If we can back up about 4 or 5 slides. One more, please, back. Okay. The other issue that is not due to just this year's drought, but has been time coming, and everybody's been seeing the press about the water issues across the western United States. Well, we've got one called irrigation, and irrigation concerns tied to our declining water tables, this looks at water level change in feet over the last 5 years. If you look in the southwest corner of Kansas at Garden City and look at those yellow to orange numbers, that is 10 to 20 foot of water droppage in the last 5 years. Next slide, please. And this is last year. And last year, we've heard 2011 mentioned a couple times. It was the largest water drop, and we averaged 1.5 foot drop last year in the southwest area. And that we have to go all the way back to 2011 to find something similar. All right. And then next slide, please. Let's go a couple. We got to jump to corn stuff. Keep going. Okay. We've seen this slide, but I mentioned the corn's the second casualty, and water's the third one, irrigation water. The fourth one's going to be the milo crop. It's a little early for me to write it off yet, but we are seeing stress on a milo crop, and I want to point out that Kansas is the #1 producer of milo production in the U.S. Texas number 2. If you add those 2 states together, you got 77% of acreage, and And as of last week, I believe 19% of the Texas crop is rated good to excellent, only 40% of Kansas. And that Kansas number was a 10% drop in 1 week. That number's coming down as well. So a good percentage of the U.S. milo crop is in dire need of moisture as well. So we'll see if that just-in-time rain maybe develops next week. Okay, Oklahoma. We moved to Northeast Oklahoma, Osage County. Oklahoma is the #2 beef cow producer as far as numbers in the U.S. Osage County is the largest county in Oklahoma, is the #1 beef numbered beef cows in the state of Oklahoma, and is #2 is cattle and calves. Is a huge cow-calf county, and we have a lot of stocker cattle coming to this region from the southeast U.S. and southern U.S. on their way on a stop to put on gain, and then they move west into the feed yard areas of West Texas, Oklahoma, and Kansas. But anyway, let's flip to the next slide. We talked about this one, so this drives at home what a flash drought looks like. This is as of the 17th of July. This is days less than a quarter inch of rain. Most of those areas now are well over 40 days because nothing's happened in the last several. And next slide, please, because as we said, we were dry from the first of the year into the end of April, and then May and the first week of June happened where we had 10 to 15 inches of rain across large areas of eastern Oklahoma. And as you can see, this is a fractional water index. If you add a 1, you're completely saturated. So as of the early part of June, we thought we were good going into summer. Grass was green, we had moisture in the bank, ponds were full, and everything was good. Next slide, please. This is a month later. If you're at a 0, you're completely dry. Where I'm living in Osage County, I have a 0. And how things have changed. Ponds are dropping. We don't have much water in the creeks or streams. We rely on them for pasture water. The drier soils are drying up. We've been understocked on our ranch with rotational grazing, and we've got pretty good grass, but like I said, the lighter soils are drying up, and you know, the cattle we're going to be able to go a little while, but water is my biggest concern. So rotation back toward the headquarters where we've got well water is a concern moving forward. Hay, we grow a lot of native grass hay, prairie hay in this part of the world that gets shipped all over. Right now, you cannot find any, even no matter if you offered a big bid, because hay yields are in rapid decline and everybody is hanging on everything to dear life. And again, a month and a half ago, we thought we were good, and how things have changed. So in closing, I would just like to say, whether it is our crop or hay operations where we get reduced gains, our livestock operations where we get reduced yields, with our cow-calf operation where we got lower gains on our weanling calves or lower gains on the stockers, or if you're in the feed yards, you got lower gains or higher death losses. All of our bottom lines are being squeezed, and this will circulate through all of our communities and regions as our profitability is being impacted. So from a cropping standpoint, thank goodness for crop insurance, and from a livestock standpoint, thank goodness for that livestock forage disaster program, because last year, Osage County, where we're at, we triggered a payment last year, and we had already triggered a 3-month factor up through the end of April this year, and so we had already qualified, but the way things are looking, we may be able to get that factor up to number 4, number 5, I think. So thank goodness for the livestock forage disaster program through the FSA and USDA, because that is going to be a lifeline for the added costs that we're going to incur. Thank you.
And thank you, Brad. Not a pretty picture that you painted, but I really appreciate you sharing your perspective with us today. We have just a few minutes for questions. We might be able to get 1 or 2 questions. If anybody would like to ask a question for either Brad Rippey, John Nelson Gammon, Lisa Larocque, or Brad Fuller, go ahead and put it into the questions box. I'm going to start out with a question from me. Brad, when I introduced you, you said that you'd been in the business for 34 years, which means that you were around for the 2011 drought. You probably, this certainly wouldn't be the first or even second drought you've seen in your lifetime, which makes me think you probably shouldn't be surprised by things anymore after 34 years in the business. Has there been anything this year in this extreme weather and climate situation we've seen this year that has surprised you?
I guess, I mean, my biggest disappointment this year in Kansas was we went through April with basically no precipitation, and a little bit of precipitation would have helped us out with the wheat crop because we had some rain in October that we established stuff. But if the rain could have happened, we ended up with some moisture in May, but it was just too late to push yields. But we ended up with a high quality crop. But the biggest disappointment now is that we are so dry out west in that western part of the state that an inch of rain is not an inch of rain anymore. And like I said, this is a combination of dryness and heat. And like I said, I think this heat over those last week where we hit 107, 108 in some of those areas, we are doing significant damage with the combination of dry and heat. And like I said, I think we're going to have some of the most significant losses we've ever seen in a long time. So the deal is our farmers, producers are eternal optimists, but after a while, and as long as this drought's gone on, and even here, it is starting to wear on people in a big way.
Oh, well, I'm sorry to hear that, and I hope that we see some things turn around as we get out of the other end of summer. But I'm hopeful. I hope for the best for you because it's not in a good place right now. I'm gonna have my next question. I'm gonna pass it over to Lisa. Lisa, you talked about some of the well, I was most interested. Well, I was quite interested when you showed the green strip on the bike lanes, and that's a very practical solution to mitigating some of the heat and impacts from heat from people that want to get out and recreate. I'm wondering if you're setting up other places around the city that are becoming almost like heat refuges or places that people they still want to get out and recreate, but they have to. But the city is set up to keep them cool, or anything in that sort of general line about setting up a heat refuge.
We have hubs that are buildings that people can go in that obviously didn't function well during COVID, but people by and large don't really like to do that because it's not a fun place. You just kind of have to hang there. And so that has not been a good model. In terms of being able to navigate on the streets, we do have a good connection with parks of all different sizes that give some respite to the heat. But I don't think that we're looking at it as comprehensively as we should. For example, the reflectivity of those bike lanes also is a safety factor, and it helps with pavement, and we need to be posing more win-win solutions.
Got it. Thank you for that. I'm going to wrap up the question time there so we can finish. We're just a few minutes over the allotted time for this. I would like to thank all of our presenters at today's webinar: Sarah Kapnick, Julie Turton, Victor Murphy, John Gottschalk, Jenny Kerouac, Nick Nosler, Brad Rippey, John Nelson Gammon, Lisa Larocque, and Brad Fuller. Finally, also, I would like to thank the many people that worked hard to put this webinar together, those that are working hard in the background here. And before I close this webinar, I would like to invite Julie Turton to turn on her camera again and just say a few closing remarks before we wrap everything up. Thanks, Julie.
Thank you, Joel, and just thank you for the chance. I simply just wanted to thank NIDIS and the team for doing this together. This is our first time out with this today, so really happy and really grateful to all the presenters here. I actually had a ton of questions for every single one of you about the heat piece, so you might hear from me later. And I hope that those of you who are watching will be in touch with questions and feedback. And our job is to get you the information you need. And so if you don't tell us what you need, we can't do it. So thank you for showing up, and please stay in touch with us. Back to you. Thanks so much.
Thanks, Julie. And thanks to all of you for joining us today. That concludes today's webinar. Just a quick reminder, you'll be able to find a recording of this webinar at drought.gov/webinars. Thanks all, and I hope you stay cool.